We are now going to move on to the spotlight talks. So just to explain, each speaker will have 3 minutes to do their talk. We're not going to take questions as they speak. If there is still time at the end, we will allow you to ask them questions. So just note your questions down, but also please remember that we have the poster sessions that will be taking place later this afternoon. All right, so I'll give over to our first presenter.
Hello, everyone. My name is Dua Mohammed. I am an assistant lecturer, and I have a master's degree in radiation physics. And right now, I don't have any cold feet or butterflies in my stomach, so we are good to go. 2 years ago, I have a personal experience with radiation. I was exposed to a high dose of radiation that it affects my tooth. I could feel them move in my mouth, and they were falling off, sorry. Next slide. And they were falling off my mouth. At the same time, continue? Okay. At the same time, I was helping my students in their graduation project. They were making a drone. So I thought, why not combine the drone with AI and with my research to make radiation studies more safer and more accurate. So right now I'm proposing a framework for smart radiation mapping. The idea is actually very simple. We can get a drone and put sensors on the drone. So make the drone fly over mountains or any area under study. The sensors will collect data, radiation data, geographical representation, and GPS coordinations. And then we can collect these data and let them go in processing, then modeling, where we can use regression and classification to predict and classify the radiation levels. After that, the system will use them to analyze, will create analysis and classify and create radiation mapping, radiation health, radiation mapping, radiological risk mapping, and radiation heat map. Of course, there are some limitations where if we add, this limitation can be in when we fly the drone, we need special permissions. Also, the sensors can add up to the drone weight, so it can affect its performance. In addition, the heat, the height of the mountains, and wind, all these can affect the readings, so we need to make calibration first. However, I already tested the idea. I already tested the idea, and I trained the model using Excel inputs from previous studies, and the machine learning system was able to create graphs, radiation heat map, and radiological risk map automatically. So these prove that the framework can actually work. My hope is to continue developing this idea so we can make radiation studies more safer and more accurate. So if anyone interested, we can collaborate together. Thank you.
Good morning, ladies and gentlemen. I am Nyakalo Kotsi from Lesotho. I will be presenting on the effectiveness of HIV treatment in Lesotho through predictive modeling using Lithia data. In Lesotho, although there have been improvements in treating HIV, drug resistance is still a critical problem. The Ministry of Health needs better ways to make decisions using data, and this project will create models which will predict drug resistance, and that will help the doctors to make decisions early on to decide whether to use the alternative treatments for patients who are likely to have drug resistance. The importances of predicting drug resistance are data-driven decision-making, early intervention, and better patient outcomes. So this project followed the following steps when I was doing my methodology part. We have data preparation, feature selection and encoding, model training and evaluation, and model selection and visualization. So the chart there shows the percentage of patients who were likely to have drug resistance due to mutation and the ones who did not. I used 2 models to train for my project, which are support vector machine and naive Bayes. So I chose these ones because naive Bayes is straightforward and simple to use, and it requires less training data. As for SVM, it is able to handle non-linear data. So I used the following matrices for predictions. Its accuracy, precision, and confusion metrics. And these were the results. So you can see on this slide, we have the support vector machine confusion matrix, which shows the true negatives, true positives, false positives, and false negatives. Thank you.
Good morning, everyone. So I'm Hazel Chamboko from the National University of Science and Technology, Zimbabwe. So I'll be presenting on a title, Twitter Sentiment Analysis on Monkeypox. So monkeypox has affected over 990,000 people around 116 countries globally. And as of mid-2025, a new clade 2 has approached Liberia and Sierra Leone linked to the US cases. So Twitter has been a key space for public discourse, but the problem is with traditional methods that have been used so far to gather public opinion. VADA and TextBlob are struggling with evolving text. This includes nuance like slang and rapid growing of our vocabulary. So the approach, we collected data using Apify to bypass API limits because now Twitter changed to X, so the API limits are a bit more now. And we use transfer learning via AutoGloon to pick the best model for our sentiment analysis. So the model we picked was an electron model from Google. It actually works better than BET because instead of masking words like what BET does, it learns by detecting words that have been replaced in the data set. So for our framework, we used CrispDM. Data was 6,300 tweets scraped. And for pre-processing, we moved emojis, hashtags, and labeled with VADA. For deployment, we deployed it locally on Streamlit dashboard. It actually works for CSV uploads and real-time predictions. Our model performance was an 83.92% for accuracy, and we also used metric values like precision, recall, and F1 score, the macro ones, because our data set was imbalanced. So these are actually the results using confusion matrix. It actually performed well on negative and neutral. As you can see, there's an 84% and 88%, and slightly lower on the positive, as it's 68%. So there's a visualization of how the dashboard looks like and our word cloud. Thank you.
My name is Kisozi Paul Kategaya from Uganda, and I'm going to talk about flood prediction using deep learning and remote sensing. It was a case study of Kampala. So, with the rise of climate change, devastating effects of rainfall, erratic rainfall, floods, drought, and famine has been on a rise. And this has been further attributed due to unpredictability in the events of the El Nino Southern Oscillation and the Indian Ocean Dipole. This has caused unpredictability in the short rains. Floods in Kampala have been categorized into 2 types, basically. We have basically categorized them into flash floods. Flash floods have been on the rise due to the low permeability of soil, the steep slopes, and the erratic rainfalls. Traditionally, floods were predicted using observation techniques. Some other cultures used to have officials that would come out to predict the floods, while others used to make marks on riverbanks. However, with advancements in technology, there has been timely prediction of floods. However, the existing models have been using the physical parameters to make predictions, which required a lot of resources, times, and expertise. This has resulted in failure to make short-time predictions of when floods would occur and when they wouldn't occur. An image there represents a flood that occurred along Entebbe Road. Cars wouldn't pass anywhere, like some would if we are stuck in jam. However, in this model, we tried to collect data from satellites, basically using satellites that had passive sensors. Mostly we got data from NASA's GPM and NOAA's GOES. These are the lead time of 0 to 6 hours. Therefore, we wanted to make predictions on if before the rain happens, and looking at other parameters. For example, if we have soil moisture, if we have the normalized difference water index, looking at the elevation and the spatial locations of these areas. So after collecting the data, we had to pre-process it. Then we chose 3 models for comparison. CNN had the highest prediction with 91.6. After, the probabilities from the predictions from CNN were later taken to ArcGIS to predict basing on the spatial locations of the areas. So, blue? Okay, thank you so much.
My name is Clivio Maria. I'm from Mozambique. I'm currently developing Linkoma. The platform designed to connect to people what they need wherever they are. So, in Mozambique, you have a lot of vendors and service providers remaining visible in digital space. Linkoma was born as a response to that reality. Across Mozambique, we face a real challenge. It's hard to find local products and services, especially in rural areas. Informal vendors look invisible behind their neighbors. Rural areas lack digital access. Many users don't know how using digital tools. Linkoma a simple, inclusive platform designed to connect to people who want something with those who have it in the most remote areas. Just you say, I want to buy an edge and fix my iron. Linkoma is instantly recommend some vendors and service providers near and new areas. We are building for our reality, light, multi-language, and used to using. We are still building, but the vision is clear, to make Linkoma a brand between the people needs and local resource. For Mozambique, for more connected digital Mozambique. I'm nervous, sorry. Thank you.
Hi, everyone. My name is Malik Lanlokun. I'm a final year master student at Nankai University in China. I'm from IndabaX Gambia, and my work is focused on emerging class discovery in large language models using semantic co-occurrence patterns. So all of us today, majority of us today at least, use LLMs in one way, shape, or form. One of the main ways we interact with LLMs is through conversational chatbots, that is ChatGPT, DeepSeek, Gemini, and the like. So one of the limitations that they have is that they are unable to evolve as language evolves in the real world. So my research is focused on ensuring that LLMs are able to self-update themselves as language in the real world evolves. Okay, so the motivation for this research is that LLMs struggle to detect emerging user intent in dynamic real-world environments. As I mentioned, language in the real world evolves on a daily basis, and LLMs struggle to adapt as language evolves. So our solution is we are proposing a lightweight, unsupervised framework for discovering emerging classes using semantic co-occurrence patterns in conversation. The key word here is the semantic co-occurrence pattern, which is the technique that we are developing. The core idea here is to use co-occurrence matrices and pre-trained embeddings plus clustering to detect novel intents. So our dataset, the dataset we are using for our research is called Clinic 150. So yes, so the methodology is to build a co-occurrence matrix to see the pairs in different conversational documents, and then do some embedding to be able to have vector representations of our co-occurrence matrix, and then calculate the similarity matrix in the embeddings to be able to know how different matrices of vectors are similar to one another, and then cluster those similarities. So this is how we are arriving at our emerging classes. So these are the results that we had from our experiment. So in the graph there, I hope it's visible to all. You can see that each color on the plot represents a cluster. In one of the plots, it's labeled as dog and pets, which means that the user that was having a conversation with the chatbot had an intention, was having a conversation with the chatbot that revolved around pets and dogs. So we have change and car, which probably revolves around car maintenance. We also have travel and plug, which means that the user's intent while using the chatbot revolved around traveling and travel accessories. So these are some of the classes that the LLM was able to come up with based on the clusters that it created within the conversational pipeline.
Good morning, everyone. I'm Kevin Bellinger. So I'm going to present on how we learn to approximate the Black-Scholes solution using the neural networks. So the Black-Scholes is a parabolic PDE, so it's mostly used to understand the dynamic of European options. So what usually we do, we use some numerical approximations such as finite difference, Monte Carlo, binomial tree, element methods, but the problem is that the Black-Scholes equations come with different assumptions, which has a constant volatility, and then these assumptions make that it's really difficult from the classical methods to understand really the dynamic of the Black-Scholes equation. So what we do, we investigate how to use the neural networks to approximate the Black-Scholes PDE. So what we did, we just built from scratch a multi-layer perceptron, and then the results shows that the Black-Scholes closed form solution and then the ANN are really close and then they match. But the problem is that the timeline from training the Black-Scholes PDE, the neural network is over the Monte Carlo simulation or the finite difference method, because we use the benchmark of difference method, classical methods. We use the finite difference method and then Monte Carlo simulation. We did some comparisons, and then we can say at the end of the day that the ANNs are really the new approach to approximate the Black-Scholes PDE. So we use different metrics. We're gonna discuss later about that. So you can approach me later, and then we discuss about how we develop our architecture and how we different metrics that we use to approximate. Thank you so much.
Hello, good morning, everyone. I hope you are all doing well. So my name is Hassi Messaoud. I'm a petroleum engineer from Algeria, and today I will present one of my research on drilling optimizing performance by reducing time and cost using machine learning algorithm. So before diving into the details, we have to get a better idea about the rate of penetration, what's the real mean of the rate of penetration. So ROP measure how many meters we're gonna drill per hour, for example, 5, 6 meters per hour. So the natural question gonna be, if we can drill with big ROP, why we only deal with 5 and 6? So this gap between the optimal ROP and the real one we use in the field, so make a difference, big difference, by the way. So we are trying to find some models to predict the optimal ROP and create this model to better confirmations. As we can see, We use for this model 4 types of algorithms: random forest regressor and gradient boost regressor, SVR, and decision tree. We can see all 4 models gonna perform very well, but when we focus for the errors, we notice that the random forest regressor performed very well because it achieved the lowest error. So we focused on the random forest regressor and build our model. Okay, so this project contains data from Hassi Messaoud oilfield, which is one of the biggest oil reservoir in Africa. And we choose 40 wells, and the data contain more than 7K data points. So we use 30% for 30% for testing and 70% for train our model. And we can see at the end we have to confirm this result, and using a friendly interface skinter window. As we can see, the result is confirmed very well from the last point of the prediction of ROP and the actual one. So we decide to take it on consideration for better results and confirmations. Thank you very much.
Good morning, everyone. My name is Patricia Ojonoka-Idaku. I'm a PhD student at the African University of Science and Technology, Nigeria, Abuja. I'm presenting my work titled Geo-parsing and Geo-visualization of Road Traffic Crash Incidents for Print Media for Emergency Response and Planning. This research work was sponsored by GSN Nigeria. So in Nigeria, as many parts of Africa, road transport is the most popular means of transportation. However, there is an alarming increase in the number of deaths from road traffic accidents. In Nigeria, road traffic crash is the #1 cause of trauma-related deaths, is the #1 cause of disability, and the 3rd leading cause of death among children and young adults. So this poses a big public health concern to the communities and societies. Another issue is that in the process of trying to work on this research, we realized that there's underreporting and omission of RTC reports in official statistics, that is national statistics. Usually, country statistics for road safety are kept by either the police or the road safety organizations. However, because of low coverage across the nation, the data is not encompassing, so it's not representative when you want to do analysis. So we realized that we needed to come up with our data set to be able to analyze road safety, road traffic incidents in the country. Also, there's a poor state of organized emergency response in the country, as many parts of Africa. So what did we come up with? Our solution is an NLP integrated approach. First, we scraped our data set from news articles, Twitter, and blogs. So the data set is textual reports of RTC incidents. And we use NLP for information extraction to extract location data, and we use geocoding to come up with the latitudes and longitudes. And we were able to create mapping for real-time emergency response, and also use the models developed for creation of a Nigerian RTC data set. Please come by our stand later in the day for detailed discussion on the research. It's really interesting, and the work has been published in Helion. Thank you very much.
Hello, everyone. My name is Sharif Dair Siad from Somalia. I'm excited to be here for my first time on a stage like this. I'm glad to be here. Our presentation is user-friendly web-based and deep learning system for TB and pneumonia diagnosed in developing countries. And tuberculosis and pneumonia are serious lung diseases that cause millions of deaths globally and especially developing countries. TB and pneumonia both can look very similar on just X-rays, making diagnosis difficult, sometimes leading to dangerous mistakes. New technologies like machine learning and deep learning, particularly CNNs, can help by analyzing X-rays more quickly and accurately, supporting doctors in distinguishing between the two diseases and improving patient care. Our problem statement is it's not always easy to know if someone has TB and pneumonia. Test scans can give the wrong result. A healthy people might be told they have TB, giving medicine to make them sick. A sick people might be told they are fine and not get treatment, which can lead to death. And sometimes doctors do not agree after looking at the same X-rays. And it can take a long time to find out of real problem. Methodology, just X-rays images from both public and private sources. We are processed and used to train several deep learning models. The top performance or the best performing model is FG19. Were combined into Ensemble and linked to a web application. This is result and comparison. Some models used. This is our system, and it's honored to be here, and it's honored to be here at this conference among such talented and passionate researchers. And thank you and a big thank you, Deep Learning Indaba, partners, companies, and everyone who worked hard to make this event possible. Thank you very much.
Physics-based modeling, neuroscience, and AI, at what point do they intersect? Hello, everyone. My name is Folashewa Abdusalam. I'm a joint master's student in neuroscience and data science at Barilan University and Vrije University Amsterdam. And I'm here to give you a brief overview of my ongoing research titled AI-augmented simulation framework for optimizing ultrasound-mediated blood-brain barrier disruption. So what exactly is the blood-brain barrier? It is a highly selective membrane that prevents substances or harmful substances from flowing through from the bloodstream to the brain, while also allowing some nutrients to pass through to the brain. While this is actually a good thing, it poses a significant challenge to neuroscientists like us that are interested in delivering therapeutic substances or drugs directly to the brain to treat neurodegenerative diseases like Alzheimer's, because this BBB also prevents the entry of some therapeutic drugs. But thanks to science and research, we found out that the combination of focused ultrasound and microbubbles can disrupt the BBB. But there is a caveat to it. Too little won't open the BBB. Too much can cause neurovascular damage, that is hemorrhage in the brain. So our goal right now is to get the safe and optimal parameters, ultrasound parameters, that can open the BBB safely. So what's our methodology? It's actually in two forms. We have the simulation mode and the AI mode. The simulation mode using the COMSO multiphysics software, where we created a 2D axiometric model of our capillary, that is the BBB, including some domains like the vessel, lumen, the blood, red blood cells, and so on. And then we defined our physics and assigned our physics, that is the pressure acoustics, the acoustic structure boundary, fluid structural interaction. And at the end of the day, we did our server setup, and we are able to get the simulation data that will be fed into our AI model in order for it to learn the parameters that will be optimized to lead to our goal. However, right now, these are the preliminary results. This is the initial simulation setup on the COMSO multiphysics, but there is something kind of wrong right now because the results are flat because we are not getting the ultrasound propagation to the materials that were defined. So right now I'm trying to get the physics to solve itself and then get the simulation data that will be fed into our AI model. If you need more questions about these old diagrams here, you can come to my stand. Thank you very much.
Good morning, everyone. My name is Ndeshafila Kakwambi, and I am from Namibia. I am from the Namibia University of Science and Technology. So my topic is developing a predictive model based on crocodile mobility for human-crocodile conflict management in Namibia. So Namibia is considered one of the pioneer leaders in conservation management. We are so serious about our wildlife that the success has boomed the population. Now with this, it started causing human-wildlife conflicts, which is the negative interactions between wildlife and humans that result in devastating consequences such as crop field damage, livestock depredation, injury, and loss of life for both wildlife and humans. So depending from your view, some people say animals are more important or people are more important. However, the truth is that both of these species are very important to the ecosystem and the economic of the country. So when human-wildlife conflict happens, the government in Namibia tries to offset the losses by the local communities by giving them money according to what they've lost, but it's never really sufficient to what they have lost. Now it costs the government millions of money. So with that, the government decided, okay, let's try to track and see whether we can create any way to predict the trajectory of the animals so that we can try and prevent human-wildlife conflict. So we are using GPS trackers which have been put on crocodiles. We chose crocodiles because crocodiles cause one of the highest human-wildlife conflicts, and normally this results in death. And so with that, the study was happening in the Kavango region over the Kavango River, where most of the locals are marginalized and live close to the river, as you can see. So how do we really move to conflict to coexistence? Now, the problem is that GPS has technical limitations that result in gaps in its trajectory. So we identified that this is a supervised multivariate regression, and this is our algorithm. So the score for the individual models was below 80%, and that is kind of like not good. So we wanted to come closer, and we had to do an ensemble average learning method, where the models then scored at least 93%. Thank you.
Good morning, everyone. I'm Caleb Adogli. To begin with, let's ask this question, this simple question. How many of you knows Togo where? Okay, it's not a problem. So Togo is a small but vibrant country in West Africa, and sometimes affectionately called a corridor separating Ghana and Benin. So a few years back now, we have been facing a problem in Togo, and the problem is that how can we securely more rapidly identify people, citizens, by the way, for administrative processes or security issues. So, and to think of that, we at Tutel, innovative AI startup in Togo, in collaboration with COTIA, the AI community in Togo, we've built a framework that uses your biometrical data to build one ID for you. So that we call FBID, stands for a framework for biometric identification. So let's see why we want to create this. Then the thing is that the past biometric system have a few issues. So the first issue is that they are sensitive to real-world situations like lightning, or maybe if the facial expression has changed. And then the second thing is that they are not built to scale. So that if you want to maybe create a unique BioID for all Africa, we cannot do it with just normal biometric system. And the third thing is that they are mostly using just one modality, like only the fingerprints or only the face. So we have built Tutel to tackle all these problems. So Tutel, we have built FBID to tackle all these problems. So FBID is built to learn directly from the data by embedding directly from all modalities that we are using. So we are using text and image, and for each of these text and image, we are using one embedding for each of them. The second is that we achieve with FBID is that we were able to bring together all these modalities so that we can, from a text, search for an image, and from an image, search from the text. So we will present our posting, so feel free to reach out to us, and thank you.
Good morning, ladies and gentlemen. My name is Leiden Sibinyane. I am a Motswana bachelor student. So for me, my research is focused on deep learning for crop disease detection in a semi-desert climate. So with the conditions that Botswana has, we have noticed that classification of diseases is vital to growing Botswana's farming economy. So Botswana being a desert nation, we lose more water than we gain each year, and due to climate change, this has been going up yearly. So for my project, I'll be using UAVs to image and collect data that I'll be needing for my model. So while doing this, I did notice that manual disease identification was slow and it was tasking. I needed a lot of labor to get this done, and it did take a lot of time. So my model is a multimodal deep learning architecture which fuses data which I collect with sensors and also images. This here is to cap the time and to detect the diseases quite faster. So the simple architecture of my network is simply just an image classification model where I use the OpenAI CLIPS model backed with a ResNet image transformer. So I also have some sensors which I have deployed all over some farms which will be collecting the moisture and other data I might need. So I also added a layer of where I'll be an attention layer which fuses the two so that I can also get a cross-attention transformer at the end. So while doing this, the key challenges I faced were the limitations with the UAVs. So I had to first get a license, get other people who are licensed in using these to deploy them and give them to be able to collect data for me and help me with this. I also noticed that we do have a limited amount of labeled data sets. So one other thing I did face was computational uneasiness on edge devices for deployment. The conclusion I did come up to while doing this was that the cross-attention was much better. It did help me. Oh, okay, thank you.
Good morning, everyone. My name is Paul Marcel Elanga. I'm from Republic of Congo. So today I'm presenting my work, SafeScreen. SafeScreen is a system designed to detect early sign of domestic abuse using NLP and psychological features. So what we want to, the motivation behind this work is that victims are often normalizing violence, so it's a serious issue and underreported. So SafeScreen, the goal of SafeScreen is to identify those signals and detect early signs and conduct those people into support that can help them if they have. So we are doing the work with, by using social media, we can reveal subtitle, sign of abuse, normalization. For this work, we collected more than 8,000 of we annotated 8,000 posts from social media like Reddit, Twitter, and Facebook. And we enrich them with psychological features such as sentiment shifts, toxic justification, and syntactic frame. We train the models with transformer models like BERT and DistilBERT. So BERT achieve accuracy of 88.7% and DistilBERT 8.2%. So here you can see, as I said, the future work for us is to make application NGOs application tools for mental health hubs too, and online moderation. And we also want to put multi-languages expansion to have languages like Lingala, Kikongo, and also Swahili maybe. and multi-label classification real-time chatbot. So as here you can see the case study, someone saying, sometimes I feel like being slapped makes me stronger, and the model predict abuse normalizing. That's what we want to do. So if you want to know more about this work, you can join me at my stand. Thank you.
Yeah. Good morning, everyone. My name is Ismail Job. I am from Mauritania. So I am going to present you my research project. It's machine learning for African languages. So 6 years ago, I was working on an NLP project, and I get some struggle to figure out how to model a topic in French. But it doesn't work well because it was French and it was in 2019. So I asked myself, if I struggle to topic a model in French, how about our African languages? That's why I started to do my research in NLP in African languages. So we all know that artificial intelligence deals with knowledge, representing knowledge, how to represent knowledge, how to store and retrieve knowledge. So the first thing I come out is that to build a model that can understand well a language, you first need to know how the language is structured, grammatically and vocabulary. That's why in my research, I worked in two main languages, African languages, Fula and Wolof. So I find out that these languages are nominal class languages, so they are a little bit different of languages like English or French or Spanish. So I understand that I must see how to represent these languages in a computer. And the data structure that work well for these languages is a finite state transducer. And I built a model that represents these languages very well because they are class nominal languages and fractional languages. The finite state transducer make us to predict the languages, the grammar of the languages, also to predict how the language is structured phonetically or morphologically. And the architecture that I used was a graph neural network architecture with attention mechanism. So for the main components are the representation of the words themselves in a graph, and the embedding, I use the sinusoidal positional embedding method, which are fixed and which doesn't require a lot of computing to train the models. And the model is based in the attention edge weighting, and I use also the graph attention network. Okay, thank you.
Bonjour à toutes et à tous. Je m'appelle Mamadou Ramata Diallo de IndabaX Guinée. Je vais vous présenter notre projet qui porte sur la détection low cost du paludisme et de la dengue par l'intelligence artificielle en Guinée. Le paludisme reste l'une des principales causes de mortalité infantile en Guinée, représentant 15% de mortalité d'enfants selon l'OMS en 2023. Et quant à la dengue, est aussi un virus propagé par le moustique Aedes, dont le diagnostic est très ardu, car les symptômes sont similaires à ceux du paludisme. Et dans les zones rurales, les tests rapides sont rares, ce qui fait atteindre plus les patients. Donc notre objectif est de développer une solution d'intelligence artificielle pour faire des diagnostics rapides et abordables, surtout en zone rurale. Notre idée est d'utiliser l'intelligence artificielle pour analyser des images de cellules sanguines pour avoir des diagnostics plus rapides. Nous avons déjà un modèle qui est entraîné basé sur le NIH malaria et Kaggle Cell Images, donnant une précision de 92%. Donc nous collectons des données locales de patients afin d'adapter le modèle et de différencier les signes de chaque maladie. Ce modèle sera intégré dans une application mobile qui sera utilisée qui sera accessible dans les appareils à faible puissance. Donc, imaginez un agent de santé qui prélève une goutte de sang et la place sur un microscope connecté à son téléphone, et en moins de 2 minutes, l'application nous donne le résultat. Ça, c'est le paludisme, soit c'est la dengue ou bien non infecté. Donc, le patient est directement pris en charge, ce qui évite les longues attentes. Donc, à résumer, nous créons une solution d'intelligence artificielle qui sera accessible, robuste et adaptée aux réalités africaines pour détecter le paludisme et la dengue plus rapidement. Je vous remercie.
Hello. Good morning, everyone. I'm Abdelaziz Sarwan. I'm representing our country, Chad. Yes, I'm from our community, Chad AI network. Chadian community, and we have this project we call Kalamna. In our local language, they call Kalamna is meaning our language in English, but is in Arabic. And we work to integrate our local languages in AI tools. Like we don't have any language from Chad in AI tools. And like example, in TTS model or the ASIA. That's why we are trying to integrate in the same time the family for the language, Sara, they call Sara, and we have like 16 dialects. Here we have like, in our country we have more than 100 languages. That is so complicated to integrate because we don't have like some alphabet, and sometimes it's so complicated to find the data. We don't have the data, and that's why we are trying to integrate these languages, and they are more underrepresented in AI tools. And we start with this project in January and trying to integrate like more than 15% from 123 languages. And here we trying to integrate the 16 languages. The 16 languages we call Sara. Sara, they are living in South Chad. They are speak, and the people who speak this language, they are more than 3 million in our country. And here, as you can see, we have like Ngambai, the tokenization for Ngambai, and the syntax. After that, we can continue here. We collect more data for these languages, more data in audio and text data, the transcription for the audio. And we have here the data for our languages. Here, firstly, we collect from PDF and the other web scraping from the website, and after that, we clean the data. As you say, the first, our data doesn't clean, and we clean. After that, we have here, okay, we have here all the data. Thank you so much.
Bonjour à toutes et à tous. Je suis Mamadou Houno Igrim, je suis tchadien, de l'équipe Tchad IA Network. Je vais vous présenter notre projet, c'est la traduction automatique de l'arabe pour l'arabe tchadien. L'arabe tchadien est un dialecte parlé par plus de millions de personnes au Tchad. 2 millions de personnes au Tchad, plus de 60% de la population parle ce dialecte. Malheureusement, il est totalement absent du monde numérique. Et notre objectif est de créer un système de traduction automatique capable de traduire entre l'arabe tchadien vers d'autres langues comme français et anglais. Et nous utilisons des modèles d'intelligence artificielle qui sont capables, n'est-ce pas, de comprendre plusieurs langues et adapter à ces dialectes précis. On a des défis à relever et parmi ces défis, nous avons peu de données à noter pour l'arabe tchadien, des variations de dialectes orales et un manque de standardisation orthographique. Pour y répondre, nous avons collaboré avec des locataires natifs Et nous approchons aussi de la communauté pour la collecte de corpus et l'annotation de collaboratifs. Nous utilisons aussi des modèles multilingues pré-entraînés pour répondre à notre objectif. Notre vision est de créer, n'est-ce pas, un modèle accessible à tous pour booster l'éducation, l'intelligence artificielle locale, et aussi des services numériques pour, n'est-ce pas, permettre aux gens de naviguer dans le monde numérique avec notre langue locale. Et aussi, à long terme, nous comptons intégrer d'autres dialectes du Tchad dans ces outils pour permettre, n'est-ce pas, aux personnes du pays d'utiliser aisément l'intelligence artificielle avec les langues. Donc, nous comptons collaborer avec d'autres personnes, ingénieurs, qui peuvent nous aider à aboutir à notre objectif final. Merci pour votre attention.
Thank you very much. My name is Tagal. I am from Ethiopia. So today I will going to present my research study entitled with crop disease detection by harnessing some ensemble model using some computer vision approach. Sorry. So, as you all know, food security is a global challenge because according to the United Nations documentations, food security is an issue of sovereignty for a number of developing countries. The world populations are expected to be 9 billion by 2050s, and there are so many challenges related with a dynamic weather conditions. On the other hand, there is a challenge of limitations with the current food monitoring systems. On the top of this challenge, there is the threatening factor is the issue of crop disease. So there is a need for technological interventions. That's why my research are mainly focused to design some sample models by analyzing image data collected by different devices. For this purpose, we have collected a number of data from local research institutes, and we trained this data by a number of pre-trained models. According to the experiment results, different models generate a different result. So, depending on the domain specificity limitations of deep learning, different models scored a different result. Then we proceed to handle this domain specificity issue. We proposed a sampled approach. This sample approach is by combining the competitive advantage of individual pre-trained models just for the sake of to build more generalizable models. We combine individual base models with sample using a weighted average approach methods. Accordingly, as a result shows, the sampled models outperform individual base models. So in this regard, we now increase the size of our data sets and the number of class, and we have gone through a number of measurement and model assessment, even using the confusion matrix to see how the ensemble models generate a better result than the other models. So in this regard, we have seen that there is a possibility of designing more generalizable models to analyze multi-image data to support the stakeholders in the domain area. So, in conclusions, agriculture is a backbone for multiple nations. So one of the promising is there is a possibility of intervention using computer vision approach. Not only computer vision approach, we have to go forward and get in-depth analysis by applying multispectral imaging. In the case of pathogen analysis, we have to consider at least the triangulation of 3 factors. One is the weather, the other one is soil properties, and the third one is host, to see which factors cause the stress and the disease. Thank you so much.
Hello everyone, my name is Hassi Messaoud, and I will be presenting our poster winner from last year at IndabaX Madagascar. His name is Mentkera, and this research is titled An Object-Based Machine Learning Approach for Thunderstorm Nowcasting. So, flash flooding is caused by rainfall, are doing significant damage to people across Africa in arid area. So the problem here is that it's hard to predict, due mainly because this thunderstorm are quickly developing, intensifying, and dissipate within the hours. So the time frame is very short for predicting them. And the traditional method for forecasting this thunderstorm are using the NWP, which stands for numerical weather prediction. And due to the process complexity of the NWP prediction, it's hard. It's too slow for quick measures and quick inference. It takes about 20 minutes to have an inference from the NWP models. And in a lot of places in Africa, there's the lack of radar coverage for more accurate prediction. So communities need a faster and more accurate warnings to save lives. So this approach is focusing on using machine learning for forecasting this, called the convective core of this thunderstorm. The first step is to use satellite data from cloud top temperature using 2D wavelet transform. And then we take the 3 nearest core location, size, intensity, and distance to predict new cores from 1 hour, 3 hour, and 6 hour lead. So we get accurate probabilities of the formation of this thunderstorm. The result was that the model outperformed the already operational meteorological model. And at the 1 hour lead, 3 hour lead, and 6 hour lead. And this is already operational, and we tested in Madagascar, in Nuspe, for saving life. Because 1 hour, 3 hours can mean more room for accurate measures. Thank you, everyone.
Good everyone, my name is Philip from Deep Learning Indaba AI Research Lab in Uganda, and I'm here to present a work that we're working on in our lab, Hierarchical CXR-Net, which is a 2-stage framework for efficient and interpretable chest X-ray diagnosis. The challenge that we're addressing is that chest X-ray images interpretation is still a problem that is faced by radiologists because we have a high volume of these, and the large number of number scans always creates a signal-to-noise problem. And the contribution we're making for the research is a 2-stage hierarchical system that mimics the efficient workflow in a clinical setting. So the data set we're using is the NIH chest X-ray 14 data set, and we are developing two models. This creates a two-stage layer. And in the stage 1, we have an efficient net B0, which separates the likely normal from the potentially abnormal images. And then in stage 2, we have the efficient net B2, and this performs a 14-class abnormality, rather classification on the potentially abnormal cases. So how did we build this? We had 2 stages, and the first stage, we just have a screener performance model, which is efficient net B0. We trained 3 models, but then efficient net B0 had the highest performance in terms of efficiency. So we took that for the first screener model. And then for the second stage, we had the expert model, which is the efficient net B2, which had also the highest diagnostic accuracy across the 14 pathologies. So we took a case study of when we ran an inference of some sample images on our models, and we could identify that the system could identify the abnormalities and then use the GradCam to create the localizations for these and heat maps for this particular image. So in conclusion, we evaluated this as an efficient and interpretable, reproducible 2-stage chest X-ray framework, and this improves efficiency by triaging images which are potentially abnormal. In our future work, we are looking forward to improving the screener sensitivity so that we do not miss out the cases, and also integrating the bounding boxes for precise localization and incorporating patient data, patient metadata to enhance the diagnostic accuracy. Thank you so much.
Good morning, everyone. My name is Saudai Sapi, and I'm representing Angola. And this works in collaboration with Albano Santos, Professor Arteza, and Chiarazo. Our work is basically to look at creating data models for managing water resources in Namibia and Angola. Currently, Namibia is classified, 83% of it is classified as semi-arid, and between Angola and Namibia, there's constant flooding, and on the southern border of it and on the northern side of it. This map shows the Kuvalai, and our focus on the Kuvalai Basin, which has a population of over 2 million from both countries. And this region usually suffers from heavy slight flooding and heavy drought. We are looking at creating models that will allow us to be able to use satellite data and observation data to do prediction and see where is water availability. Our main question is, how can we translate Earth observation data into reliable ML feature ready for prediction? Our research is basically based on, that's what we're trying to achieve. That's our objective, and that's what we're trying to solve for. If you look at this is a graphic of data we have that classifies the water that's availability within the map. Throughout what we get from satellite, we have a resource data from Sentinel that we look at, and then we do classification based on pixel data using the KAN model or the KAN algorithm, nearest neighbor algorithm, to be able to predict the water presence within the satellite data we have on the Sentinel and so on. When we have each pixel of data is compared to its nearest neighbor to see what availability of whether it's water or non-water pixel. We look at the different architectures, so what we're focusing on is to look, we extract the data either from Sentinel, two from Google Earth and all other sources. We process the data and then we upload it on our models, and then we save the data to the relevant data source, and we extract that data and we start doing we pass it through a training model, the KAN, to process the data, and then from that we start now doing the prediction of whether we have water source or we have no water source. And this is very essential because it assists the government in with the ability to say, in these areas during flooding, you don't have to walk a long distance. You can just, here's a point of presence where there's water, and as a government, we can basically create a source for you to be able to have that water. Thank you.
Mesdames et messieurs, bonjour. Je m'appelle Mohamed Mokhtar, je viens du Niger. et j'ai l'immense plaisir de vous présenter mon projet de recherche intitulé AgriStat. AgriStat, c'est une application qui permet de compter, de détecter et d'estimer le rendement agricole à travers la vision par l'ordinateur et le Deep Learning. En 2025, les agriculteurs continuent toujours de compter leur nombre de plants à la main, ce qui les fait perdre énormément de temps et aussi ça fausse leur estimation en termes de rendement. C'est pour remédier à cela que nous avons mis en place AgriStat, qui va non seulement automatiser tous ces processus, mais aussi leur permettre d'avoir une estimation réelle, fiable de leur rendement. Pour mettre en place notre modèle, nous avons dans un premier temps recueilli 1000 images à travers un drone de haute résolution et le capteur RGB. Par la suite, nous avons utilisé l'AppleMe pour faire l'annotation de ces différentes images. Et par la suite, nous avons utilisé le modèle d'entraînement YOLO version V8. Et à la fin, nous avons mis en place une interface qui va aider les agriculteurs via Streamlit, qui a une fonctionnalité offline, c'est-à-dire qui marche même sans connexion Internet, ce qui est l'idéal pour les agriculteurs qui sont dans les zones non électrifiées, non connectées d'immense. Ces résultats montrent que notre modèle est très performant avec une précision de 0,92 et un recall de 0,90, MAP 50 de 0,94. Ici, vous avez l'interface de l'utilisateur, c'est-à-dire lorsque l'agriculteur veut faire une estimation, il va prendre une photo soit via son téléphone, soit via un drone ou bien via une image satellitaire. Lorsqu'il va uploader, automatiquement, notre modèle va essayer de lui faire une prévision comme suit. Ici, vous avez l'ensemble des plants qu'il a eu à cultiver sur son champ. Vous avez le périmètre, vous avez la densité, vous avez aussi l'estimation en kilogrammes de ce qu'il peut avoir à la fin de sa récolte. Et mais encore aussi, il a une estimation en termes de coût. Ce modèle va non seulement permettre à l'agriculteur d'avoir une meilleure vision de ce qu'il aura à la fin, mais aussi ça peut être un outil d'aide à la décision. Je suis à la fin de ma présentation. Si vous voulez en savoir plus, je serai de l'autre côté et je vous répondrai avec plaisir. Je vous remercie.
Good morning, everyone. My name is Fatma Issa from Tanzania, and I'm here to present my research, which is on prediction of cryptococcal meningitis among HIV and non-HIV in Tanzania. So the motivation of this research was due to the limitation of confirmatory tests in primary health care. So, So we did a research on how we can create a machine learning model that can predict the cryptococcal meningitis among HIV and non-HIV. So what we did, we collected data from referral hospitals in Dar es Salaam region, where we collected them from 2022 to 2024. And then from there, we trained several models, machine learning models for classification purpose to identify the model that can be robust for this work. So from the training of the model, we evaluated the model accuracy by using the cross-validation, and then we identified the important features through permutation importance, as well as we did the parameter tuning so that to identify which parameters can optimize the model. From those hyperparameter tuned model, we selected the model which had at least 60% of the accuracy, and we retrained them so that to obtain the final model. So from the retrained of the model, we finally obtained the ADA boost, which was outperformed the other model with the accuracy of 69 and the 78% of the area under the curve. So to explain the contribution of each feature in classifying the model, we used SHARP, where we try to understand which feature contributed to which class. So from there, we identified 4 features which had more contribution to the positive prediction. Thank you.
Good morning, everyone. Good morning. My name is Ariane Wetohosu. I am from University of Abomey-Calavi, and I am representing IndabaX Benin Republic. Today, I'm delighted to present you my work on tomato yield prediction in Benin using machine learning. So as we know, agriculture is the backbone of many African economies. It provides jobs, formal and informal jobs for millions of people. It contributes to the GDP and also food security. Yet farmers face many challenges, including climate variability and predictability, poor access to technological innovations, and also they are unable to predict yield. Yield prediction can help them to better plan the production, optimize resource uses, and optimize also the yields. So this work aims to predict tomato yield in Benin using machine learning model. For this purpose, we conducted 3 greenhouse experiments considering different weather parameters and also 5 treatments. We collected data on tomato growth and also yields, and we pre-processed those data. We split the data in 80-20 for training and test, and we use classical machine learning model as well as Ensemble model. At the end, we found that Ensemble model outperformed the other models, especially the extreme gradient boosting, who achieved 90% of R-square. In addition, minimum temperature and the treatment 1, which combined 25% of organic matter and mineral matter, was found as the important predictors. Thank you for your attention. If you want to know more about this work, please come to my poster and I will be happy to exchange with you. Thank you.
Hello, everyone. My name is Pacific Nyongabire from Burundi. My poster is titled Enhancing Teledesk Transaction with CNN-based fingerprint recognition. Here the question is why to enhance the teledesk transaction? How about the existing systems? As you all know, the bank industry or the bank, it has seen significant change over times due to the advancement of technologies. In 1967, they initiated the ATMs in London. And as the years go by, we've seen that the mobile banking, internet transactions, and so on. So you found like though there are those advancements, there are a significant number of customers who prefer to do face-to-face transaction at the bank teller desk. So the problem you found like they have to fill out the withdrawal form, then the bank teller has to record the information to the existing system. And it is somehow time-consuming. So we come up with the idea of implementing a system that a customer will just scan his finger, then insert the amount he wants to withdraw, and then after, the bank teller will allow the transaction if it meets the amount that he has. So the current state, we are integrating CNN for faster recognition, but again, there we want to reach is to combine the fingerprint branch, but again, the ESG branch for further implementation. For whoever wants to know more about this system, you are welcome. Thank you.